In this video, we will demonstrate our design project. Our topic is, should an autonomous vehicle equip a rear-end collision avoidance system? In the United States, California is the only state which demands companies test autonomous vehicles and report collisions. In 2018, California Department of Motor Vehicles, also known as DMV, published 49 autonomous vehicles collision reports. DMV data shows 28 of the collisions were rear-end, which makes almost 60% of the total. Another report declares 22 of those rear-end collisions happened when autonomous vehicles were in the self-driving mode. Now, let's watch a short animation which shows a classic rear-end collision on an automated car. In this video, although there's no dangerous situation in the front, the AV identifies the tree as a pedestrian by mistake and makes a sudden stop. The following car doesn't expect this and crashes on the AV from behind. Now, let's take a look at the value map related to our topic. In our map, we have 9 stakeholders. Each of them has its own values. The 9 stakeholders are the owner of the AV, the driver of the vehicle behind, the system designer, the manufacturer, the regulator, the rescue service, the media, other vehicles and pedestrians, and the insurance company. We also demonstrate 9 value tensions in this map. However, we will not cover them all in our analysis. Instead, we will only focus on one key value tension. In this part, we will conduct a detailed ethics analysis on one key value tension. Among our 9 value tensions, we choose the tension between the carefulness of the system designer and the comfort of the driver behind as our analysis object. This tension is closely related to our topic. Due to some reason, the system designers don't want to develop a rear-end collision avoidance system, while the drivers behind want it, because it may improve their driving experience when following an AV. From the system designer's point of view, first, the system should try to avoid any potential accident in the front, even if it causes a sudden stop. This is their first priority. Second, implementing such rear collision avoidance feature may bring new risks to other vehicles and pedestrians nearby. Third, in most countries, the car behind should take the responsibility in a collision. However, the drivers behind don't agree with the current design. They feel uncomfortable with the weird behavior of the front AV. They especially hate the sudden stop because it is one of the main causes of the rear-end collision according to the lawsuit statistics.
In this part, I will discuss about 3 resolutions for our tension. They are dissolution, compromise, and trade-off. Most rear-ended collisions happen because of uncommon driving styles of the AV. To create a human-like autonomous system, at first we have to implement a 360-degree data collection system, then train the driverless car with this data. However, all of this require a huge amount of user data and advanced technology. Therefore, it may take years or even decades for our researcher to dissolve the tension fully. Now the designer may apply a compromise solution by implementing a more straightforward features such as find an escape path to avoid the collision and trying to maintain a proper distance with the following car. Furthermore, the rear-ending driver has to drive carefully if the front car is in autopilot mode. I will cover this section with more details in the prototype part. We can choose the trade-off resolution where the driver in the rear-ended car take all the responsibilities. But ethically it is not right, because previously we showed many data where the self-driving front-end car actually responsible for rear-ended collision. Right now, in our opinion, the compromise resolution can play a crucial role to avoid rear-end collision in some simple situation. So, for the prototype, we divide this resolution into 3 parts.
We represent 2 possible system designs. There is one thing to point out. These designs should not bring any new risk to other stakeholders.
In this design, the autonomous car should maintain a proper distance and speed from the rear-ended vehicle. To implement this, we need backward sensor, wireless communication, and lidar. To process this data, we require backward data processing unit, which will control the velocity and space. If the autonomous car can sense any awkward action from the backend, then it can immediately change the lane. For this design, we want lidar, left sensor, right sensor, and backward sensor, a smart electric steering actuator, and rearward data processing unit needed to process the data. As we know, the rear-ended happens because the rearward driver does not know that the front car is an AV and not expect the odd movement. So, each AV should install a display screen or a spatial light on the top or back of the car. When the autopilot is enabled, the screen displays auto mode or switch on a spatial light to warn the following driver. With this information, the driver behind will have a clue and become more cautious. Here, the lawmaker should play a vital role by enforcing some new regulation. At first, an autonomous vehicle without an autopilot indicator has to take partial responsibility in a collision. Secondly, after a collision, police have the right to check all the system data of the AV. Thirdly, make some regulation to prevent another vehicle follows an AV too close. At last, AV cannot be in autopilot in some particular area in some specific time, and also limit the lane for an AV in the highway. To sum up, I want to say that the compromise resolution can work good for some simple situation, but it is not perfect for any critical condition. For example, in the situation B and D, we do not have any idea how the autonomous car will behave because there is no particular escape path. In the situation C, the AV can take the left lane, but it is risky and uncomfortable for the pinker which comes from behind. So, to resolve the problem entirely and offer a futuristic model for the next generation, we should choose the model which we propose in our dissolution part. Moreover, we already provide detailed description of that model in our prototype assignment.